I'm Chaz Frick, a Systems Applications Engineer in the Aerospace and Defense Group at Analog Devices. Today, I'll be introducing the Quad MxFE Phased Array Radar Prototyping Platform, targeting L, S, and part of C-band. The Quad MxFE is intended to be a reference design and includes several key features. An onboard power design solution from a single 12-volt supply to provide all required power rails. A complete clocking solution from a single 500 MHz reference clock input. This includes 4 ADF4371 PLLs to generate the sample clock to each MxFE, and an HMC 7043 to distribute reference clocks and JESD sysref signals. An RF front-end design for the frequency band 2.7 GHz to 3.7 GHz, including amplification, filtering, and digital step attenuation for the RX path. However, other variants of the board change the frequency band. A software reference design including FPGA HDL with JESD 204B and JESD 204C cores and an embedded Linux image. A MATLAB add-on and control interface including example application scripts and a customer GUI. An FMC Plus connector to interface to a Xilinx VCU 118 FPGA board. The top side of the Quad MxFE board contains the pinout of the 16 RX channels of the ADCs on the MxFEs. Near each MxFE is a 5-volt fan connector. Additionally, there is a single 500 MHz clock input to the board, and the ADF4371s can be seen. The HMC 7043 is also located on the top of the board. The top of the board also features the 12-volt connector and the power switch. The bottom of the board features the 16 transmit signal chains for the DACs on the MxFEs. The corners of the board feature the power solution using several micromodules. Lastly, there is the FMC Plus connector. Now, let's talk about the kit. The AD Quad MxFE 1EBZ kit contains the Quad MxFE board, FMC Plus extender board, board standoffs, fans for the MxFE chips, 2 SMA to MMCX cables, 2 MMCX to MMCX cables, and a 12-volt power supply and wiki instructions link. The Quad MxFE board connects to the FMC Plus extender and then to the VCU 118. In order to interface to the Quad MxFE board, an Ethernet cable and 2 USB cables must be connected to the VCU 118. These allow for programming of the FPGA and configuration of the Quad MxFE. In this setup, the Ethernet cable connects to the laptop via a USB to Ethernet dongle. Do not use the Ethernet cable from the VCU 118 kit, as this is a crossover cable and will not work. Fans from the kit should be installed on the top of each MxFE. Additionally, an external fan to cool the setup is recommended. See the fan installation video or wiki for more information. With the setup put together, the FPGA and Quad MxFE can be powered on and programmed. At this time, we will apply a 500 MHz 0 dBm clock signal into our Quad MxFE board. We also connect a calibration board to enable combined TX to RX loopback. For more information on the calibration board, please see the calibration board unboxing video or the wiki. The FPGA is then programmed to boot Linux and configure the Quad MxFE in one of several use cases. After programming, we run one of the MATLAB example scripts provided with a MATLAB add-on. This script performs a system calibration using the programmable FIR filters in the receive path of the AD9081s. Other examples provided with this add-on include multi-chip synchronization of all the MxFEs and a low-latency ADC to DAC loopback within the part. After running the script, we are shown the calibration and equalization results across our frequency band. At this point, all the channels have been aligned in phase and amplitude. Thanks for watching. For more information, please visit analog.com.